Hello, welcome to this video. In this class, we will learn how to find out the properties of steam. If we are familiar with vapor dome, the left side of the vapor dome is saturated liquid, the right side of the vapor dome is saturated vapor, and if we talk anything beyond this right side saturated vapor, we'll have superheated steam. And to the left side of this saturated liquid, we'll have subcooled liquid. Now, in order to find out the properties, we know that if we talk about anything on saturated liquid, in our data handbook, it is denoted by suffix F. If we try to find out the properties, anything on this line, it is denoted by the letter G. Okay. Now, let us say, for example, if I ask, what is the enthalpy of saturated liquid at 5 bar? I can always go and find out from the table. So, I will go to pressure based table, and at 5 bar, we also know the saturation temperature, which is 151.85. I will go for HF, which is saturated liquids enthalpy. So, 640.1 kilojoule per kg. 640.1 kilojoule per kg. Now, similarly, I can get enthalpy of saturated vapor Hg at 5 bar or 10 bar, whichever question is asked, we can solve that. Now, Hg is here. At 5 bar, the enthalpy of saturated vapor or dry saturated steam is 2747.5. 2747.5 kilojoule per kg. Now, similarly, I can find out entropy of saturated liquid, entropy of saturated vapor, Vf, which is specific volume of saturated liquid, Vg, which is specific volume of saturated vapor. We can find out at any given pressure. Now, so the moment it is saturated liquid or saturated vapor, we can copy the values of this directly from the data handbook. Now, what if the the given steam is somewhere here? That is, this is saturated states is directly you are copying from data handbook at given pressure. Now, the moment it is wet steam, the equation which we are going to use is let us say within vapor dome. So, within vapor dome. So, the moment I talk about within vapor dome, we come across with the dryness fraction x value. So, if x is 0.5, it will be somewhere here. If x is 0.8, it will be somewhere here. If x is 0.2, it will be somewhere here. So, it is like HF plus x into HFG. Similarly, if you want entropy, SF plus x into SFG. V is equal to Vf plus x Vfg. Now, this HFG, SFG, these are all HFG is difference. Hg minus HF. Vfg, similarly, SFG is Sg minus SF. Vfg is Vg minus Vf. Okay. Now, for example, at 5 bar, let us say, at 5 bar, he has given the dryness fraction is 50%. We can find out H is equal to HF at 5 bar. We can copy plus x, which is 0.5 multiplied by HFG. Now, HFG is directly given there. I will go back to the table. Now, HF at 5 bar is 640.1 plus 0.5. See, HFG is already given. He has subtracted 2747.5 minus 640.1. That is, he has done Hg minus HF and he has directly tabulated. Now, this will be 2107.4 and we can find out enthalpy of wet steam at given dryness fraction. Okay. Now, this will be in kilojoule per kg. Now, we have learned if the steam is on saturated liquid, we can find out directly. If we have steam on the saturated vapor, we can also find out directly. And if it is wet steam, we can use these formulas to find out the properties. What if it is a superheated steam? So, in generally, superheated steam will be given with both pressure and temperature. For superheated steam, generally, both pressure and temperature will be given. For example, let us say at same 5 bar, temperature of the given working fluid is, let us say 300 degrees Celsius. Now, what I will do? At 5 bar, I will check what is the saturation temperature. At 5 bar, the saturation temperature is 151.85 degrees Celsius. Therefore, the given steam is superheated because it is greater than T saturation temperature. Given steam is superheated. So, the properties has to be properties from superheated table. Properties to be seen from superheated table. Now, I will go to the superheated table. For example, I have taken for pi bar the absolute pressure in bar and the T saturation temperature is also given here, which is in bracket 151.8. Now, there is volume, specific volume, there is enthalpy and there is entropy. And you can see that this is the temperature at which we can note down these properties. There is no question of F and G. F and G comes into picture when we are talking about saturated liquid or saturated vapor or within vapor dome. So, we are talking beyond the vapor dome. So, obviously, there is no question of F and G. Only one property will exist, that is specific volume, specific enthalpy and specific entropy and so on. Okay. Now, for 5 bar and 300 degrees Celsius. So, this is 5 bar and temperature is 300 degrees Celsius. We can note down these properties. Okay. At 5 bar and 300 degrees Celsius, the specific volume is 0.52258 meter cube per kg and enthalpy of steam is 3064.8 kilojoule per kg and entropy is 7.4614 kilojoule per kg Kelvin. So, we can take few more example and try to solve, but this is the idea. For the given pressure, if the temperature is greater than T saturation, go to superheated table and from superheated table, you can copy the properties. So, we have learnt in this class how to find out the properties if it is saturated liquid, if it is saturated vapor, if it is a wet mixture and if it is a superheated steam. Thank you.